Hi, my name's Sarah. I'm with Atlassian. I work in the developer tools business. I'm in marketing. Before I was a developer tool marketer, I was a user of developer tools. I was a test automator for a number of years. And so I get really excited still about test automation and continuous integration. And so it's awesome to see so many people gathered in a room here to learn more about CI. So yay, quality. So we're going to talk about the intersection of Git and continuous integration, and I'm going to walk you through some best practices and some optimizations that you can try out on your CI system back at home. So actually, before I confirm my agenda, how many people are already using Git? Okay, so anybody not? Okay, so I will go through the why Git section. I wasn't sure if I actually really needed to explain why you should use Git, but it sounds like I still have to win a few people over. So great, we'll start with that. And then I'm going to go through, like I said, some optimizations and some tips for getting your CI server to interact nicely with your Git repository. And then we're going to walk through some Git hooks towards the end of the talk that you can use to bolster your CI system. So, why Git? Okay, so we know why it's great to make software as a team instead of as a single person. You get different ways of thinking and different backgrounds, different approaches to problem solving when you have a team of people working on something. And when you bring all those things to bear on whatever problem you're trying to solve, you end up with better software. You tend to get software that's more maintainable, that has higher quality, and usually it ends up serving the user better as well. But we also know that making software as a team can be very, very messy. But the good news is that Git makes it really easy to control some of that mess by dividing up pieces of a project into sort of like isolatable chunks of work that you can pull down onto a development branch or a feature branch. So you can work on that chunk of work and make your own mess, basically, without making a mess for the rest of your team. And everybody can do this in parallel. So the basic workflow is usually that developers will make a development branch off of master and implement the feature or the bug fix down there. And then when they're satisfied that that is at a certain level of completeness and quality, the work gets merged back upstream. So it's really, I think the biggest advantage of Git for teams is all about the branching capabilities. But you say, well, SVN and Perforce and ClearCase and whatever else, they all do branching too, right? Which they do. But I'd like to introduce you to branching's evil twin, the merge. So traditional VCSs like SVN are just not that great at tracking different versions of files that live on different branches. And so when it comes time to merge those two branches together, merge those files together, SVN has to stop and ask you for directions a lot. Do you want your piece or their piece? What do I do here? So it's a very painful manual process, this merging thing. So teams tend to avoid it. They will maybe even set lots of administrative controls that prevent people from creating branches in the first place just to avoid the pain of merging. So you then end up with a workflow where basically everyone just piles all of their changes onto one code line, usually trunk, which then becomes rather unstable because the code isn't getting tested before it reaches trunk. So trunk is then very unstable. It's difficult to release from there. And it's even difficult sometimes to sort through why the build is failing because you have 30 changes or change sets that just piled on. But Git works differently. Git is actually really good at tracking different versions of files that live on different branches. It's almost sort of like it has like a built-in GPS that it can use for triangulation. So when it comes time to do the merge, it very rarely has to stop and ask you, the developer, for directions. So this makes merging a really trivial operation in Git. And the upshot is that you then become free to exploit the power of branch and merge workflows in a way that, sort of practically speaking, you just wouldn't with a traditional centralized version control system. So that's my sales pitch for Git. Every team at Atlassian is now using Git. We had some on Mercurial, but even those have switched over to Git now. And we are really, really excited about feature branching. We are so excited that we create a branch for every single issue that we work on. If it's a bug fix, a user story, a refactoring task, it doesn't matter. If it's tracked in our issue tracker, which you may have heard of, it's called Jira. So if it's tracked in Jira and code is getting committed, it gets its own branch. So for example, just in the Jira code base alone, we have 775 branches. Now Jira is composed of many small repositories, so that's a factor to keep in mind. It's not like a big monolithic project, but still, that's a lot of branches. And I just show that to illustrate that we're serious about this branching thing. But by keeping that work in progress isolated down on those feature branches, we can keep master in that clean, releasable, usable state, which helps us deliver faster than we've ever been able to before. So this is the basic workflow that we use. It's just kind of what I mentioned before. You've got dev branches that are created off of master. When the work is okay to ship out, it's merged back upstream. And all of those little arrows, or circle arrows, are places where CI is running. So the point that I really wanted to make with all of this is that Git makes it really easy to keep unproven code off of your important code lines. And CI makes it really easy to prove out the quality of your code while it's down on those feature branches. So for that reason, I think these two concepts or technologies come together in a really powerful way. So with that in mind, let's start talking about the CI stuff. And we're going to start with your repo, which is where everything begins. So one of the things that you may have heard about Git already is that it's a bad idea to be tracking large files in your repository. So this is things like pre-built binaries or libraries of images, that sort of thing. And the reason for this is that once you add a file to your repository, it is always going to be there in the history of your repo, which means that every time that your repo is cloned, so somebody pulls it down to their local workstation, that huge heavy file is cloned right along with it because the entire history gets cloned by default. So even if you realize your mistake and you take that large artifact out of the current snapshot of your repo, it's still there. And removing it from the history requires something on the order of like a frontal lobotomy on your repository. It's possible, but I don't recommend doing it yourself. You usually have to hire a consultant for that, and it's very expensive. Anyway, keeping large files out of your repo is especially important if you are doing CI. And the reason for that is that every time you run a build, your CI server has to pull code down to the build agent. And so you don't want it having to pull all those heavy, huge files along with it because that eats up disk space for one thing, but more importantly, it just draws out that cloning process and makes your build run slower. But what if your build depends on large artifacts? That is a really common situation, and it probably will be a common situation for a very long time. So the question is how to handle it effectively. And for that, you should probably be using some sort of external archiving system. Nexus is, I think, an open source one. There's also proprietary ones like Artifactory. You could even just find a spare desktop tower that's living in somebody's cubicle unused and set that up as a temporary file server on your network. The point is not to keep the files somewhere else besides your repository. So then at the beginning of the build, you can reach out to that artifact, the archive, and pull those artifacts in at the same time as you're pulling in the code from your repository. So it's done in a very similar way to how you pull in third-party libraries with Maven or Gradle or what have you. So speaking of cloning, like I said, each time a build runs, your build server pulls down the code in your repository. It clones your repo. And as I mentioned before, when Git clones a repo, it clones the entire history of the repo by default, unless you use something called shallow clones, which are really useful for CI. So with a shallow clone, only the current snapshot of your repository is pulled down. So this is really useful for reducing build times, especially if you have a repository that's been around for a long time and you've built up quite a bit of history in there. But again, there are exceptions to this too. Let's say that your build requires the full repository history. If you want to be if you want to be writing changes back to your repo as part of the build, depending on what version of Git you're using, you might be able to do that with a shallow clone. But if you're doing a complex operation like doing any kind of merging as part of your build, which I'll talk more about in a minute, shallow clones are not going to work for you there. In order to do a merge, Git requires that the full repository history be present in both the local copy of the repo and in the copy of origin in your Git server. Because it needs that history to triangulate the common ancestor of the two versions of the file that you're merging together. If you're going to do something like that, the better bet is to cache the repository instead of pull down the full history, but cache it. And you cache it on your agents, your build agents. I just realized that I'm in Europe, and being in front of a European audience, there may not be many people who recognize the show The Americans, but these are secret agents. So yeah, the joke really falls flat if you don't have the proper cultural context. Sorry about that. Anyway, you cache the repo on your build agents. Note that repository caching is only going to you're only going to get any benefit from it if you're using persistent build agents. So if you're using EC2 or another cloud provider to spin up a build agent, run your build, tear it down, and then spin up a fresh one the next time you run your build, you won't get any benefit from repository caching because your cache gets, you need a persistent agent from build to build in order for the cache to actually be present. So shallow cloning and repository caching, pretty slick ways to manage the load on your CI server, first of all, but also really manage the build times as well. All right, so let's get on to some branching stuff. Now, whether you make a branch for each issue like we do, or if you do branching sort of maybe at the sprint level or more at the multi-story epic level, you will end up with quite a few branches in your repository. And if you're already working with Git, you know that feature branches tend to be fairly short-lived. Ours tend to live for about 2 or 3 days. Nonetheless, it's really important to run CI on all of your feature branches. Otherwise, if the first time you run any tests is when you're merging up to master and run CI there, you'll get hit with all kinds of nasty surprises. Master is going to be, it'll be big and red and unreleasable and unsuitable for making new branches from, and that situation sort of defeats the purpose of using a branch and merge workflow in the first place. So how do you set that up? How do you bring CI down to your feature branches? Well, the old-fashioned way is to make clones of all your CI configs and then point those clones at the feature branch. But that is really a drag, especially if you've got a whole lot of builds running. The new-fashioned way is to make your CI server do that for you. Make the robot do it. If you're using Jenkins, there's a plugin called the Build Per Branch plugin that will discover new branches in your repo, and it'll do this cloning and pointing the clone at the new branch thing for you. But I can't resist pointing out that that plugin is actually a less robust copycat version of the branching support that we built into Bamboo. So there's my plug for Bamboo. Either way, the point is to spend less time configuring your builds, more time writing your code. So now we've got feature branches running CI, but at Atlassian, our teams discovered one small problem with this. So we have probably close to 600 developers now, and they each push changes to their branches several times a day. And if each commit is getting built, that is a lot of builds. And unless you can scale your build server like instantly and infinitely with build agents, your queue is going to get really backed up. So for example, just one of our internal Bamboo servers, it's got 935 different build plans on it. And we've plugged 140 build agents into that thing. And still, the build was getting clogged, or the queue was getting clogged up. Even after we instituted artifact passing and we started parallelizing our tests, like still the build queue was getting clogged up. So what we found is that a good way to balance testing rigor with build resource conservation is to make builds on the dev branches push button. So developer checks it, pushes some code. Maybe this time you think, no, I know my tests are going to all fail right now, but I still want to push the code anyway. Then you do some more coding, push that, and you're like, okay, now I want to run that build. So we leave that up to the developer's discretion. And you're sort of partly on the honor system to run the CI on your dev branch, but that really gets enforced when you go to merge upstream. However, for critical branches like master and any stable release branches, well, they're critical branches, and we decided that we wanted to have feedback on those on builds on those branches all the time, every time, and get it as quickly as possible. So for those branches, we use an automated build trigger. So let's see. So we've covered cloning, repository caching, triggers, and I want to shift gears a little bit at this point. This is a common objection that I often hear when you're talking about continuous integration and feature branching. It's not pure CI. And that's true. It isn't. You don't have everyone piling every itty-bitty little change onto one branch. But that's kind of the point of a branch and merge workflow, because using that single code line, again, tends to make it very unstable and hard to work with. However, pure CI does carry the advantage of knowing right away whether the changes that you just made conflict with the changes that your neighbor made 5 minutes ago. So then how do you get the best of both worlds here? How do you get feedback about integration without creating chaos on a branch that the whole team needs to use and maybe release from? So I'm going to talk about 3 different methods that you can try out and sort of maybe mix and match a little bit. The first is to rebase your development branch during development. For the few of you, the 5 of you who aren't working with Git yet, rebase is you basically reset the commit of origin for your branch, and then Git replays all the changes from your branch on top of that. So in animated form, it looks kind of like that. So rebasing your rebasing your branch and then running a CI build on the rebased branch provides a reasonable preview of how the new code, the new changes that you made, will interact with everything else that's already up on master. So if you're going to go this route, it's a good idea to do it maybe once a day, and for sure do it right before you do your final merge upstream. Rebase, however, keep in mind, rebase is best for when you are the only person working on that feature branch. Otherwise, if you rebase a branch that other people are working on, it's going to mess up their local copies, and they're going to have to spend a whole bunch of time reconciling the local clone that they've got with what you've now done to the repository of origin, and they will probably be very grumpy with you for making them spend time on that. So be nice. Don't rebase somebody else's branch. It's not cool. So another popular option is to have your CI server merge master or your branch of choice, but I'm just going to say master for now. Merge master down into your feature branch each time you build, or again, at least do this once a day. So this solves a couple problems. It prevents your branch from drifting far away from master, and it shows you how your changes on your branch are going to interact with the work that's already up on master. There is one caveat though. Basically, I'm just going to repeat what I said a few minutes ago. Shallow clones and merging don't mix. So if you're going to employ automated merging on your builds, cache the repository instead as your time-saving mechanism. Now, despite the caveat that you can't use shallow clones with automated merging, I still think it's a really worthwhile thing to do. And it offers some advantages that rebasing your branch doesn't offer. For one thing, the history of your repository remains perfectly intact. For U5, when you hear people get scared about Git because you can rewrite history, rebasing is what they're talking about. But if you're merging, you don't have to do that. Second, you can completely automate this merging business with your CI server. And I'm unaware of any CI server that supports like automated rebasing out of the box. And the third advantage is that when you automate this with your build server, you will get to choose between using that the CI run against the merged code as kind of an FYI, just a preview. This is kind of how it's going to go. Or you can actually opt to have your CI server push that merged code down to your feature branch, assuming all the tests pass, so that that pulls code right down. It makes that push for you. You can also actually have it push the code the other direction, push it upstream. So if you're working on something that the rest of your team is depending on, you can be feeding those changes up to master, and then the rest of your team can have access to them. So it prevents you from being a bottleneck. Now, I'm not 100% certain whether that Jenkins plugin that I mentioned will support automated merging, but I do know that Bamboo does, so plug number 2 for Bamboo. And even if you're not using either of those tools, you can always do this with a simple script. It's like 3 lines, like check out branch A, check out branch B, do the merge, and then at the end of your build, you could have the optional push. So really easy to script. Oh, that's what it looks like in Bamboo. Okay, and the third option that's even closer to pure CI is to include a shared integration branch in your team's workflow. This is really similar to the Git flow way of doing things. So basically, when you've got a clean CI run on your feature branch, merge up to the integration branch, like so. And the first time you do that, you'll probably find some conflicts with things that other people are working on. So you go back to your feature branch, and you try it again, and you sort of rinse and repeat this cycle until you've got all your work implemented, and you've got a green run down on your feature branch, you've got a green run on integration, so you know it's all cool with everything else that your teammates are working on. And at that point, then you can go back to your feature branch and just pop that sucker all the way upstream to master. So what was I going to say here? Oh, right. So I do think that it is best to merge your feature branch straight up to master. Even though you've got a green run on both places, integration branch may have some code on it from your teammates that isn't quite ready for prime time yet, so they might not want that to merge upstream yet. And the other reason is just for traceability. You can see here in my example, I've named my branch feature dev-45. Well, dev-45, that's an issue key. Right? If you're a Jira user, that format is probably familiar to you. But every issue tracker out there has some unique key for each issue. And by including that issue key in your branch name, when you do something like merge it up to master, it makes it really clear to the other people on your team, the other developers, as well as your project stakeholders and people like your release manager, exactly what was merged in. And so they will know that, oh, dev-45 was merged in. I can see that merge commit really clearly in my repository. I know that that issue is ready for release. Whereas if you're merging integration up to master, you'll just see like integration, merge, integration, integration. Like all your merge commits will look the same, and you don't get that same level of clarity and traceability. All right, let's talk about hooks. So hooks are sort of like Git's plugin system. They let you hook into certain Git operations and then customize how your repository behaves. So if you look in the .git directory of your repository, not now because I have your rapt attention, but later, if you look in the .git directory of your repo, you'll find some example scripts. So there's 2 basic classes of hooks. There is client side, which live on your local workstation, and there's server side, which live in the repository of origin. They live on your Git server. And you can also categorize hooks by pre and post. So pre-hooks get invoked before the Git operation that they're tied to, and if the hook script has a problem, it can cancel that operation. Post hooks happen after the Git operation has already completed. So it doesn't have the option to cancel the operation, but it basically lets you carry out further tasks. So you can do things like with a pre-received client-side hook, you would run this before, let's see, I guess it would be a pre-commit hook. So you could run check style as part of your commit process when you're doing a local commit. And if you have blockers or severe violations from check style, Git could just reject that commit. Same thing with pre-receive server-side hooks, like a pre-push server-side hook. You can use that to check to make sure that the push coming in meets certain criteria, and then reject the push if it doesn't. And I'm going to talk a little bit more about those in a second. Post hooks, a good example would be adding additional files to your workspace. So going back to talking about large files and not tracking them in your repo. If your project requires large files, you could have a post checkout hook that lives in your local workstation, where as soon as you check out a new branch, that post checkout hook will then go out and fetch all those artifacts and binaries and whatnot and bring those into your local workstation for you. A post receive server side hook, easy example is whenever you push to the repository or you or your teammate, it notifies your chat room. So there's a ton of stuff that you can do with Git hooks. They're really powerful. But it's these guys, the pre-receive server-side hook, that I think is such a great companion for CI. So developers, I think, are generally conscientious enough not to merge into master or into a stable version branch when there are broken tests on the branch that they're merging in. But sometimes we forget to check, or sometimes we're working off of a shared branch and the person that we're sharing the branch with breaks some tests and we're not aware of it. So it's a nice thing to add a little bit of extra protection around master, and you can do that with a pre-receive server-side hook. So my colleague, Tim, who's sitting right here in the audience, wave, Tim. This guy here wrote a couple of really cool Git hooks and put them on Bitbucket, one of which checks for incoming merges to master, and then when it sees an incoming merge, it will go out to your CI server, it'll look for the latest build on your feature branch and just check to make sure that that latest build is green. If it's green, everything is cool, you can go ahead and do the push. If it's not green, this Git hook will actually cancel the push operation and let you know that you need to go back and fix the tests on your branch first. So that's a cool one. Now, something else that I've seen teams struggle with is maintaining code coverage. Our last speaker talked about how difficult it is to get code coverage, especially on legacy code. I mean, you saw that he had their team set like a 40% code coverage goal for legacy code and an 80% coverage goal for new code. And it, especially if you've gone back and written tests against old code, it is so frustrating to see that hard-fought code coverage number slip away gradually as you and your teammates check in more production code that doesn't have the appropriate level of tests to go along with it. So we can use a Git hook to help make sure that that situation doesn't happen. So this is another one that Tim wrote. It, again, looks for incoming merges to master. Again, a pre-receive server-side hook. When it finds an incoming merge to master, it goes out to the CI server again, looks at the code coverage stat on your branch, and then looks at the code coverage stat on master. If your branch has inferior code coverage, you don't get to make that merge. It'll stop the merge or halt the push, and then you have to go back and figure out where you need to add code coverage. And just to be clear, like this hook that I'm talking about assumes that you are already running code coverage as part of your build. It just goes to your CI server and looks for the two stats. It doesn't actually do the code coverage run for you. Anyway, these are really useful, and you can download them both and a few others, I think, at this address. This is a Bitbucket repository. So, and how am I doing on time? Who's keeping time here? We have 3 minutes? Okay. I think I'll leave it there. Key takeaways I want you to go away with. Definitely let your feature branches do the dirty work for you. Keep that dirty code off master. Employ shallow clones and repo caching whenever possible. Please, please, please get CI running on all your dev branches. You'll thank me and thank yourself, more likely. That one I didn't cover, sorry. We didn't have time. And then do take advantage of Git hooks as well. They give your repository sort of ninja protection powers, and they're really cool. And I'll leave you with 2 free things. If you are a Git guru or a Git newbie and you prefer pushing buttons to typing commands at the terminal, check out SourceTree. It's a really nice GUI client for Mac and Windows that layers on top of your Git repository, makes it really easy to work with. And especially if you're new to, actually no, gurus and newbies alike can enjoy, Atlassian.com/Git. This is kind of our Git tutorials and microsites. So if you're just getting started, it'll take you through a lot of the commands and the workflows. If you're a Git guru and want to find out what's new in the latest point release of Git, we've got coverage of different topics like that on the microsite as well. So I guess I have like 2 minutes for Q&A. Yes. That's right. Right. So the client-side Git hooks, like when you make a local clone of a repository, if your teammate has a client-side Git hook, you won't get that. So we don't really have first of all, we don't have like an enforced standard around using these hooks. We just sort of offer them up, and people can use them or not at their discretion. But for client-side hooks, it is up to the individual to install that on their local workstation. Server-side hooks, obviously they live on your server, so everybody gets to take advantage of that. Please. Right on. Other questions? I probably have time for like one more. Okay, I guess everything was crystal clear. Well, if you think of questions later, I'll be around, so come chat me up. Thanks.